Hello everybody, that you came out so early so we can share the beauty of hashes with you. It's nerdy stuff, but I hope you like it. In 15 minutes we will glance at the beauty of them. What we do is we do training, and also we train trainers. So if you are interested in joining us, what we do is that we teach about blockchain in easy wording. We try to use symbols and analogies to explain the complex field of blockchain. And maybe you see a few examples of that in my presentation. So what is a hash? A hash is a very dirty bastard, in fact. It's 64 characters. But it's a proof of any amount of data. And that can be one character, or that could be a whole hard drive. A hash consists of, hashing consists of two parts. It's data, the dirty bastard that I just mentioned, and also a program that is open source. That's the hashing function. And why does it need to be open source? You can trust it. Why do you trust it?
Because you can see it.
Sorry?
Because you can see it.
Because you can see it. Is there any other reason why it's open source?
With many eyes, eliminates the possibility of an error within the code.
That's true. That's true too. So the open source, many eyes make bugs shallow.
Everyone can verify.
Everyone can verify. We can hash the function itself. We can hash the hash function. Enough nerdy stuff. Let's go over what blockchain, what the essence of blockchains is. Blockchains are a coincidental invention. It was made purposely by to be an e-payment system. But when they took out the engine, it appeared to be applicable in many areas. And the reason for that is that we use the op return field. You can forget about that if you're not into Bitcoin. Let me first ask a question. Who owns Bitcoin in this? Okay. Who's here for the first time ever on a blockchain meetup? Okay. Thank you. So yeah, exactly. Thank you for coming out. So then I can confront you with the only thing a blockchain can do right away. And so you might never forget that anymore. The only thing you can do with the blockchain is to put a certain proof in the blockchain that is time-stamped. You make it time-stamped. You say, I know this proof now, today, so that I can verify it in the future. That's the only thing a blockchain can do. There is nothing on the blockchain. If people say to you, we put the real estate on the blockchain, we put the medical file on the blockchain, that's all bullshit. The only thing they put on the blockchain is maybe a proof of some data at some instance. Okay, and how do they do that? With this beautiful hash. It's a really fantastic thing. Look at it here, the beauty of it. There you've got it. This is a very famous hash. It's another hash, you see. And it's produced by the hashing function. We will look into more detail quickly. Who knows this hash? Does anyone recognize it? But you were there yesterday. That's not fair. That's not fair.
Yeah, I think because it is some zero. I think this may be the hash of the Genesis.
Exactly. This gentleman is right. It's the hash of the Genesis block. What is the Genesis block? Would you want to know? I can't tell you because I only got 15 minutes. But it's the first block ever in the Bitcoin blockchain. And it needs proof. We need proof that this block is still valid. And we need this proof. We needed this proof 9 years ago, and we need it today. And we will need it in 20 years as well. Which is a different story. But what we can do is fingerprint, timestamp, so we can verify it later, that it's exactly the same fingerprint. And that is one of the beauties of a hash. How does it work? What is it? So you go to any open source hash calculator, and we use SHA-256 for this example. Why? Because it's heavily used in Bitcoin. and in many blockchains. So we could use the letter A, you see it here, just on the side of the screen, and it produces this hash. It will produce this hash today, it will produce this hash in 20 years, and it produced this hash 20 years ago. And that's really beautiful, because we have now a way to verify the proof. Who knows this text? I think many people might recognize the text. Okay, thank you. So Martin Luther King, if he had a blockchain available back then and he knew that it was a very great speech, it was a great speech back then, he could have produced this hash to prove that he invented this speech. So this speech is a total different hash. You see? It's not even close to the other one here. See that? Why is that? Why is the hash different? Sorry? Exactly, there's a full stop missing on the end. You see this little tiny prick here? It's missing. That's the only thing that's missing. And what happens here is that there is resulting a totally different hash. And that's beautiful. We need that very bad. We need it very badly. Because we want to have, in one eye contact, we want to see that somebody tampered with the content. He took the dot away. And why do I all tell you this? Because if you really understand the true meaning of technology, it might work in a positive way for you. And if you don't, you might have a problem. So I told you about the function. This is the function. Don't bother too much about it. Just wanted to show you that cryptographers have invented this a long time ago. It's heavily used, heavily tested, and it really works. Only quantum computers will try to break it in the future, and if they do, no worries, we will invent another SHA algorithm. Yeah? So don't worry, don't listen to the people that are trying to break with quantum computers a SHA. They will eventually, but we will run forward. This is the wrap-up of the beauty of a hash. It's collision-free. That means if you have one hash of 64 characters, there is no second source that could produce that hash. So there's always one single source that produced that hash. And that you would say, well, no, I will try to find some source that produces exactly the same hash, but that's impossible. And I can't explain you now why, but it is. The second thing is it hides. And what that means is that you can't find any source data from the hash itself. This is the character A as a source. You can check that on your mobile phone. That is this hash. But you could also say, put in a whole block of the blockchain with 4,000 transactions in it, and you produce one hash here. And you see this hash is has 13 leading zeros, and the first hash I showed you was 10 leading zeros, and it has to do with the difficulty in the blockchain of the Bitcoin. Maybe somebody else will explain you, and if not, come at me at the break. I will explain it to you. So what happens here is that you can put in any data, and it will be hidden by its hash. It's collision-free, as I told you. So, and it's also a message digest. You could most probably think of this woman talking a lot the whole night, but the end result is that she's happy. And this proof, you could attach that conclusion to the proof and say she was happy. If you want to listen to the whole story, use the proof and find out about the content. How that works is we take the whole block in this case block 210,000. We produce the hash and we check it now. So we can check it because it's on the blockchain, we check it now, and if we do that, it is exactly the same hash. And we know that not a single byte will be different from that source here. So it's verified. And that's the only reason why we use blockchains, because we can verify data by its hash. Feature 2 is hiding. It's a double commitment. And you have to give me the amount of Valerie. How much time do you have left?
5 minutes.
Sorry?
5 minutes.
Okay, good. I'm doing great in that perspective. So what we have here is a seal, more or less a seal. So it's a two-way commitment. Why it's not a one-way commitment? Because you receive the proof of the hash. Why is it a two-way commitment? Could anyone give me a hint? Or did you fall asleep by so much nerdy stuff? No one dares why it's a two-way commitment? Over there? Public and private key, no, that's a different a cryptographical building stone, which we can't go into detail. We have 5 building stones. One is a hash, second is a hash pointer, public-private key pairs, signing, and also encryption. But we do one at a time. We are looking at hashes, okay? Now, the reason why it's a two-way commitment is that as soon as I get the hash of some data that, for example, this lady here saves very cautiously on her own hard disk, as soon as I've got this proof of her hard disk or some document on the hard disk, and I would refer to that proof later, she has to supply the exact document. It's a two-way commitment. Yeah. If she doesn't, then the hash will be totally different. If she tries to change a single byte in the document, it will not work. And the last feature of last natural beauty, and we can wait. Just pick it up. I've got 5 minutes left anyway, so don't worry. Counting down. All right. So it's puzzle friendly, and how do we use that? How do we use the puzzle friendliness of hashes? What? Sorry? In mining, exactly, and also in difficulty, exactly. So in mining and in difficulty. So what is puzzle friendliness? If I throw a dice that will give me 1/6 of a chance of a 6, and it doesn't matter whether I have already thrown like 20,000 times, my chance that the next will be a 6 is again 1/6. Okay. So that's puzzle friendly, and the production of a hash is totally random in the same way. So nobody can gain advantage by buying, what we say, a super hasher or something like that. It's a fair game. Yeah. You can buy a lot of computers that do exactly the same hash function. That is exactly what's happening. So all the mining farms, they buy a lot of hardware that runs the same protocol over and over again, because you have to try. It's random. Well, I think I went through at least 3 beautiful features of hashes. One was the collision-free. You can't produce 2 hashes. You can't produce with 2 sources 1 hash. The second is the hiding property. So you can hide the information and still have a commitment to that. And the third one was puzzle friendliness. So I hope that you will never ever forget about the beauty of hashes. And if you want to follow me on Twitter, I will, not every day, write my love songs about hashes, but I have now and again some details about what I think of what's happening in the field. Okay. Thank you.